All right, so I feel like we should just start now. It's currently 3:33, and today we're going to talk about scanning and enumeration. So, scanning and enumeration is one of um, the first steps onto the hacking methodology. It's where you look at what you're dealing with, the operating systems and the machines that you're dealing with. Sometimes you could even tell if it's what kind of server it is or what kind of if it's a web server or a mailing server, stuff like that. And so the agenda for today is we're going to talk about both scanning and enumeration, and we're going to focus on one particular tool that is called Nmap, Network Mapper, and we're going to see how can we automate these processes, right? So let's start with scanning. Scanning is a set of procedure for identifying live hosts, ports, services. We could discover operating systems and as well as anything about the target. So vulnerability, although it's not going to tell us the actual vulnerability itself, it's going to tell us, well, with Nmap, of course, it's not going to tell us the vulnerability, but you could use it to find out vulnerability about that particular like version of Apache or version of any kind of server that they're running, you know, the services that they're running, which poses a threat to their network. So we have different kind of scans. We have network scans to determine IP address, operating systems details, and topology details. And we have port scans to see what ports are open. Port 80 is for HTTP, port 53 for DNS, and vulnerability scan in which scans for known vulnerabilities, in which looks for particular flaws often. So in a lot of Windows Server back in the days, there was particular flaws that was bugs, and they tried to infiltrate the system by using those bugs that they found. That's why these need to get patched really quickly before they get um, exploited. And enumeration. Enumeration is a process of extracting usernames and machine names, network resources from a particular system. So they usually are already scanning and they have a particular port that they're looking for. Um, and based on that port, we're trying to target a specific port for specific information. So in this case, I have two examples, in which is TCP53, in which is TCP port 53, in which is a DNS zone transfer. And what they do is TCP53 is a very vulnerable port because of the fact that they tell a little too much about the DNS system. The DNS server tells you about their name, they tell you their operating system. So the intention is good. However, we have switched toward a UDP53 where if it's kind of malicious or a weird kind of connection, they're connecting through a private IP or they're connecting too many times, they drop it. And that's what UDP has to offer other than TCP. Another one is TCP and UDP 389, and this is what LDAP for Lightweight Directory Access Protocol, I believe, or Active
Yep, no, that's
Directory.
it. That's it.
Yeah, okay,
LDAP. Yeah.
protocol. And this usually in most cases this port are disabled on the firewall from the outside because the fact that once you have access to this kind of port, you're able to see kind of Active Directory inside. You're able to see the kind of structure of the whole entire tree of how they're set up. Not necessarily you're not in it, but you could see. Seeing in this case is gold mine. If you could see what's inside of a network without even being in the network, you're basically like X-ray man right there. And you're able to gather data, you're able to gather um, information, and these information are costly. It's very expensive, sometimes it's confidential, and a lot of times we are dealing with uh, personal identifiable information, so names, IP address, employee numbers, and those are the things that we need to watch out for. Exclusivity and integrity of our files, so make sure that nobody else could have the chance to alter it and also change it or see it. So today we're going to talk about Nmap. Nmap, I think, is the greatest tool when it comes to scanning, and it is a tool that allows us to discover hosts and services on a computer network. I think it's capable of probing. Probing is just scanning, looking over, sending packets not expecting an answer, but using those packets that we send as a way to determine if the host is open or any kind of information that we could draw back from that packet being sent. Usually it's an ACK packet or a SYN packet, depending on what it is that you're trying to accomplish. And I will tell you later the kind of scripts or the kind of scans that they do. It is a cross-platform tool, so all majority of all operating system have it. So Mac has it. It's just that you require different um, libraries, and because of the fact that Linux already have it pre-installed, you need NCAP for Windows, and I believe for Mac, I'm not quite sure, but you need to figure out what you need for Mac. I've only used it for both Linux and Windows. And the scan techniques that they have multiples, and they're used as flags. So the switches are what you put in front of the target that you want to scan. And these targets are usually one server or one particular system, and you're using it for a specific specific techniques, right? So we have first the SYN port scan, in which is a default scan. It tells you what kind of ports are open. It tells you the services, and then it also tell you the name, the services, and the port number. The TCP connect port scan is a scan that you do not need uh, to do root for, so you don't need to do sudo. And this is basically just they usually configure this scan to be, if it's a private network, they usually close all connects ports because of the fact that they don't want you to figure out based on a regular scan. Um, we have a UDP scan, a TCP ACK scan, a window, and Maven, right? So UDP is a specific type of server. So it's TCP and UDP, and they're depending on the service that you want to look out for, they tell you different things. And in our case before with the enumeration, we see that TCP 389 and UDP 389 gives us the same kind of information, but they're both block. However, the TCP 53 and UDP 53 gives us different information. Hence, you would probably try to target the TCP first, and then if it doesn't give you anything, maybe we try the UDP. Or based on how you feel, that based on your recon initially, because before we talk about the dumpster diving, and those information are incorporated with what you do from this point forward. And ACK port scan is a part of the three-way handshake. So ACK scan, if you send their SB to SYN, and then a SYN ACK, and then they send a SYN back to finish the three-way handshake. And if you send an ACK scan, they will send back saying that you haven't sent us a SYN, and also it's like kind of a failure. However, with that, they also tell you what it is that who they are and what they are. And with that, you know some information before you do anything else proceeding toward your research for vulnerabilities. Um, Windows scan and Maven scan, I'm not quite sure because I haven't really used it, but it's another type of script. So these are basically scripts that are embedded within Nmap already. So this is tools that we could use on a daily basis. So this is in a lot of hacker or penetration testers toolkit. Nmap is the number one thing that they use. And host discovery. Host discovery is basically you identifying what port you want to use, uh, the target, if you have a list of a target, and then you want to see what kind of it's based on preference. The PN usually is I use a lot is the dash capital P lowercase n, and that is for if your host is not giving you too many answers, so you just continue sending until one of them does give you answers. A lot of the time they just tell you that, oh, they're not giving us anything back, so they're trying to disable the whole script, but you want the whole thing to run to see if this part of the scan does kind of trigger some kind of response out of the entire list of ports. There is 1,000 ports that they scan, and from that 1,000, usually public ports, they do give us an answer. And this is a different type of host discovery that you could do on top of the scripting before. so you could stack these switches. And the next one is service and version detection. So with this, you're able to see what kind of services that they're running. Um, as lowercase s, capital V is the most common one that we use. However, you could be more explicit with the things that you want to do. So version light is you enabling a mode, and then the version intensity is you are trying to i- increase the possibility of correctness by continue trying different kind of version and asking them if that's what they are. However, this does trigger on the other side, kind of if they have a logging system of attempts of connection, this tells them that you're continuously trying for one particular IP address to their side, and then maybe there's a potential where you get your IP get banned and you're not able to do this command anymore. And that's why there's these modes that exist, because the fact that they want to make sure that uh, they are not getting hacked. Of course, that's their goal. Safety is their goal. However, our goal is to get in. Um, so the light mode is trying to get the most common, like if port 80, the most common services, they will try those instead of trying all the different combination. They will try the ones that kind of common, so this will be run faster. The higher intensity will run longer, and then if you do OS detection, that will also take a certain amount of time, which takes actually pretty long. And the next part of that is the timing and performance. The the switches for the T's is basically the timeouts for the actual Nmap scan. If we do T5 and T0, T0 will do it every, let's just say, 1,000 milliseconds. So it'll be really slow. I'll send one packet, I'll wait for the response comes back, I'll wait. I do another one, I wait. And this is for that whole process of trying to not seem sus. We're not trying to get banned. And on their log, it says that how come this IP is continuously trying every single port that we have. So what we do is we use timeouts to make sure that they don't recognize these patterns that we're doing, right? And then um, the T0 to T5 is already predetermined the speed. T3 being normal, T2 being polite, sneaky, paranoid, and these are based on different numbers for how much timeout they will give. However, you could also pre-configure how much timeout you want to give them. Let's just say it is a pre-configured bot that is a part of a challenge, and they tell you that if you continue getting requesting or sending ICMP packets, and it will ban you if you do it too often, then you will know how long you want to do the timeouts for. And the retries, the minute, how many packets you want to send per second, you could also determine that. So it's not only how long do you do it in between, but also like how many times you do it within the minute. And then um, that's about it for the time. Okay, so I'm gonna show you guys the difference, kind of the difference in the kind of scan that we do. And we're gonna do it on the Hack the Box server because of the fact that finding a target is one of the hardest thing. Because if you try to map a corporate network, they'll probably ban you and you probably go to jail. Um, okay. Alrighty. You know what? We're just going to okay. So in a way for us to do that is we first have to go to the network, and that's one of the way. I'm using Tmux as my terminal because Tmux has those thing in the bottom where I'm able to make tabs without opening. And also Tmux is amazing because it's session based, so you could pop it on and pop it off. It's an amazing tool. Um, and we're gonna target a box called Blunder, and it's a Linux box. And so what we're gonna do is first to see the nmap, you to see what it does and kind of the manual for it, you would use the man tool to see what it is, and this will tell you all their capabilities. I'll tell you kind of an example of a scan and their summary and all their tags with the minimal description. But if you forget what kind of tags or what kind of flags you need, you could just refer to this manual. And let's see first what would happen if we have the regular mmap without any privileges or any kind of privileges or flags, right? This is a regular connect scan, and it tells us what kind of ports are open, but that's about it. So it tells you the state of the port itself, and the service. So if in a connect scan, they will probably tell you the TCP ports are open and their service that they're running, in which majority of the time you would already know that based on the port number itself. Common ports already get associated to a service. Port 80 is HTTP, 443 is HTTPS, and those are already kind of industry standards that you already know. And if we were to use a version, right? This was a version, and then we would be able to see what kind of version it is. However, when you use a flag, when you use it, okay. If you're using a flag, if you're using a flag that is just um for versions, you don't need to be sudo. However, if you're running different scripts, you need to be a root user. So let's try if we are trying to use one of the different scripts like st. I believe st was the root one. Oh, that's without root. So we want to try with the root. So let's just say a syn port scan, which probably will give us the same answer because that's how you initiate a connect three-way handshake. And and it says that this requires a root privilege because this is a exclusive script, although it will tell us the same thing, but it is a script that they're saying, you would need to know what you're doing for you to use these kind of scripts. And so we're gonna try to use sudo nmap. We're going to do that. Going to see the versions. And with this, we're able to see using the script that is the exclusive script that they have, and using the flag for version. We're trying to find the version. We're trying to see what they have, and within that amount of time, it takes a little longer, I believe. It takes a little longer. However, it was a throw scan, and based on what it is that you wanted, and we were looking for a SYN scan, and this is what they give you: the port number, the state, the service, and the version. And a lot of different servers, we're dealing with multiple machines, so this will take ages. If one scan would take 11 seconds, imagine a server that has 100 computers or 1,000 computers, right? These computers within different regions of the department. Let's just say we're talking about like a big bank. The finance department and the IT department would have two different configuration. And if we're trying to hack into the bank itself, we would need to know the kind of services that are running within these two different versions and configuration of these two boxes. And with that, we would need to kind of see how can we scan through everything, a clean scan through all the different machines on the actual server itself, and that's where automation comes in. You want to be able to incorporate this tool to maybe like a bash script or you want to incorporate these tools, there's actually a way for you to scan um, all the possible. If you guys know, you're able to like make it into, I forgot what it's called. I think it's DIRC or CR, DICR notation, in which you're able to run through all the possible computers within a private host by one line. So you tell them how many hosts are inside of that one IP address section, and you tell them the subnet mask, and then they are able to use that and calculate what the numbers based on just an iteration of the numbers on the end, on the far hand side, this side, to figure out the private network. So with that, you're able to scan through each computer if they're using kind of like an incremental IP address. However, sometimes you know the machines that you want to scan and you have a list of it. And with that, you would need to create your own script based on your preference, what it is that you want to put in, how you want to retrieve the information. And that would be amazing with Bash script. And I want to hand it off to Alex to talk about Bash scripting today.
uh, within another script you make. So you can create a series of scripts that have sort of this array of functionality, like a sort of personal tool bag that you crafted yourself. So I'm only going to be going over the first few slides in this full presentation because I made this end of the presentation as more of a glossary of all the materials you might need to get started. And so there's a bunch of topics on here, such as the if statements and loops, where rather than going through the slides, I'm just going to demo it for you. But if you download this presentation, in which we threw in the announcements channel, you'll be able to go through this yourself, and you should have all the materials to get started on your own. And as I demo things, feel free to start up your own VMs and type up some of these scripts and try to run them yourselves. Although I might have to go through it somewhat quickly because we have fairly limited amount of time, but at least you'll get to see how this works or get a general explanation before diving it into completely fresh. And I'm not sure, maybe some of you have done it, but I'm going to try to approach it from both the perspective of someone starting out completely fresh and also showing something maybe a little cooler that's actually going to be working off of the stuff Alex showed with Nmap. So, all right, let's get to the next slide, sorry. And so these are some of the absolute requirements, things you need to do to make a bash script function. So let's see. And prerequisites. Since you can script any possible Linux function that has a command line interface, you can make a script, but then to run it on other systems potentially, those other systems might not have that function that you call upon within the script. So understanding with each script all the prerequisites of things you make use of is important to keep track of. Although with the scripts I'm going to be showing you, it's all going to be sort of vanilla bash, and then additionally just making use of Nmap. So there's quite a bit you can do with just sort of the vanilla functions available to you with bash itself, but any specialized program, you'll have to make sure that it is there on a particular system. Then next, you got the header, which is the first line. Oh, no, it's still just the next thing on that slide. But the header is the first line of code in a bash script, which is the hash exclamation mark, no spaces, /bin/bash, which is just sort of the code way of the system being able to recognize of that it's a type of script, a bash script in particular. Naming conventions, normally you just have it with no dot extension at all or a .sh. This comes into play when you try to get it to be a natural command of a system, which is a thing you can do. In order to run a script, you sort of have to state the full directory path of the script, which is sort of the /directory script name.sh, or sometimes if you're in that directory already, ./script name.sh. You can also make a script, like I said, part of a system's natural coding structure by putting it in the /bin directory in a Linux system or the home/bin directory, because those directories are in in a system's path variable. And the path variable is a concept that sort of spans most systems like Linux, Windows, and multiple coding languages. And what that means is where are the places in a system that a command line interface will go to look for the definitions of a command. So if you install a new coding language, you'll have to add its libraries to the path. And so even though it's a specific bit of information, it's one that's good to know when you're dealing with any sort of coding. All right, next slide. And permissions. Now, permissions is a whole topic, and it's one that can be its own presentation altogether, but you do need to know at least this much. So within Linux, the general permissions are read, the ability to just look into the contents of a file; write, the ability to change the contents; and execute, the ability for that file to take action. And in Linux, it's structured with those three permissions given to the owning user, then another set of those three to the owning group, and another set of those three to everyone else or other. And you can see that in the little screenshot I listed. So with each file, the permissions are on the left-hand side. And along with that is the owning group, which in this case on my computer is a user named org, and then the owning group, which is a one called cyber for each of these scripts. And so the bare minimum of what you need to do to get a script to run is give at least the owning user, assuming in this case it's you, the execute permission, which is done with this with the chmod space u plus x, which means the owning user is given the execute command followed by the script name and full path if that's necessary. So I also added a link if you want to learn more about this. It's pretty important in regard. Linux permissions is important if you are interested in cybersecurity as a profession. It can be a bit dry, but it is important to know how that all works. But for the purposes of this, you just need to know this one command, the chmod u plus x script name. All right, so let me see. Do they need the next one? All right, so everything after this point, there's 6 or so additional slides with just more content in regards to how it's going to break. It's got important commands, useful tips, variables, if statements, loops, and output management. So you can go through this as you see fit to be able to get a better understanding of how to start with making your own bash scripts. But now I'm just going to demo some stuff. So I'm going to share my screen now. And we're going to go to my VM. So you guys might have to swap over to watch my screen to see what I'm doing now. So let me I'm gonna need some vocal or text communication once you guys are over and you're seeing my VM. Let me know because I don't want to move on until you guys are ready.
We can see your VM.
Sweet. All right. So I'm going to, right here on the right-hand side is a sort of basic script that gives you the structure of if statements and loops and is there to sort of help you with the logic of how it's laid out. Even if you know another coding language, the syntax or the exact characters, spacing, and patterns the system needs for it to recognize what it's being told to do. So let's go through this at the top. So I gave 3 examples here, 2 if statements and a loop. The first one, you got your starting header here. And then every other thing, let's just go through each of these components and break them down. So any line followed by sort of a hash symbol or number symbol is a comment. And that's important in terms of having text to write down that won't be acted on as code so that you can keep track of what something is, either to yourself or a team of people that might be working on the same script, or to people that you might be giving the script to, but they don't understand what this component is doing. So this one just says, first example to demonstrate numeric comparison in an if statement. Next line, we got x equals 0. We are declaring a variable, x equals 0. Pretty simple there, but important to note, no spaces. Declaring variables, there's a different way you do this for different types of data. So there's a different way to declare a variable when you're making it based off of the outcome of a function or when you're doing pure mathematical computation. Again, that's in the slides I gave you all. So it's a bit different for when you're trying to store information in a variable in a different type of context. So you might have to do some research on your end if it's a different type of thing than what you see here. All right. So, and this is storing variables is very important in regards to how you pipe information to make something automated. Anything that you list as a flat value might only work for that specific context of whatever it is you're doing. But by using variables and managing them smartly, you can intelligently rather, you can make something a open-ended dynamic system that accounts for a multitude of scenarios. So that makes something a powerful tool that can be used in many, many different situations. So going on next, you got the structure of an if statement. So starting with if space open bracket and close bracket to give the context of a scenario. Now you're sort of calling on a variable, making use of a variable you previously structured. And wait, okay. And to do that, you use the the $sign before the name of the variable to call on it. Then you've got -gt for greater than and a numerical value 1. So you're saying if the variable x is greater than 1, you then have double pipe symbols. A pipe symbol is the shift symbol of the backslash right below the backspace. Double pipe is logical OR. So what you're saying here is if variable x is greater than 1 or variable x is equal to 1, then, so semicolon is a new line. And so let's see. So typical structure is you wouldn't have this and you'd have just the new line to say then, but you can just make it one concise thing by having that structure and semicolon then. It's just a nice way to put it, but might be a little bit like a lot of details that you're going to have to remember. You might not get everything at once, but going through this, it'll get more familiar as you go through. And echo. Sorry, anybody have a question?
I have a question?
Yeah, go for it.
Yeah,
Man.
I have a question. For the greater than, can we use a greater than sign?
Greater than sign, yes, I believe you can in these instances. But sometimes they also have additional context. So that's an option as well. But in terms of everything I show you, there will likely be multiple ways to do every action. So I've given you all the fundamentals.
I'm getting confused with the Python scripting. Is that
no. This is all Bash. Python, Bash, two different things. A lot of coding languages will have the same logical components. If statements, if else, and all that stuff. That's a universal because it's a universal concept between pretty much all coding languages. If a coding language does not have it, there's probably a reason for it, but it's a core concept, but the syntax will be different, meaning the exact character you use to express a certain type of logic will be different, but there are certain things, if statements, loops, these are all sort of universal coding concepts. And the way each language approaches it might be a little different or have just different symbols representing it. So just because it's an if statement doesn't mean it's akin to Python, but Python is another useful thing. So not to be confused, though. All right?
Gotcha. Okay, thanks.
All right, no problem. So now going back to the section where we're at, echo is a command that tells the terminal to print a certain value. And you can say, and in quotes, the term do this. So now that you understand the structure of how that's laid out, you then have an elif, which means else if, another potential condition. X is equal to 0, then you have the double ampersand. This is logical and, so both conditions need to be correct. And then this one is x is less than 1. Then this result happens. The tabbed thing in association with this, echo, no, do that. Then you have an else statement. An else means if all prior conditions failed, do this action instead of anything else. In this case being echo, maybe do something. So, a little bit of audience interaction based off of what's going on here. If I ran this script, what do you think this output would be? Anyone?
It would be no, do that?
All right, we're going to hold, because when I run the script, it's going to do all of these things. So just, I'll remember your answer. Your answer is no, do that. We're going to get back to that. But I'll run the script at the end to see if you are right, and then we'll go over it. And then now, second one. This is for comparing a string. So we're stating a variable y equals the string hello. Then you got an if statement. If the variable y is equal to hello. So for string comparison, it's a double equals sign, not -eq. So there's differences between numerical and string comparison. It just graphically makes it look like it's a single equals because that's a thing this Kali does. So if y equals hello, then echo it's true, and then elif is the other condition. If y does not equal to, which in this case is exclamation mark equals. So while it looks like that, it's the two things that you're going to be using are exclamation mark equals. If it equals by, then echo this is true too. Phi is also to complete a logical statement. There's always a completion indicator for if it's the opposite of if, or the inverse of the spelling phi. All right, so in this situation, what do you think the answer is?
It's true.
All right, cool.
Quick question. What is the phi for?
Phi is the completion of the if statement, so that it doesn't get confused as any other code being other scenarios or other conditions. So you need it to, when you're thinking about the logic of coding, you don't think simply it is from beginning to end, but when you're analyzing it, you're thinking about it in blocks. And so this is sort of an if block, and so this is the beginning of it, the middle of it, and you need the end of it for it to logically compute in the system when it runs it as bash code. Does that make sense?
Yeah, so basically to complete the whole script, unlike other programming languages, you need that fi.
Exactly, correct. And the other type of logical statements will have their own, and it's a little some are like different words from the opening clause, and some are like the inverse spelling. Bash is sort of weird with how it goes about it. So, but just if is the closer for it is phi. All right. So, and again, the structure of this, in case like if you forget the exact syntax, I have this all written out in this presentation, which you're free to download yourself, all right? All right, so now let's go through the third example, which is a loop statement. So in this one, we're defining the variable x as 0. And now there's two core loop statements, a while statement and an until statement. While is while the condition is true, and then until is until the condition is true. So the until would be as long as the condition is false, and then it'll stop once it's true. But while is as long as the condition is true, and the second it is false, then it'll stop cycling itself. So while the value of x is less than 3, do this. So that's also the structure, kind of like the if statement's then bit. You have the semicolon for the new line, and do. Do is the thing that continues the loop sequence. Then it says, this is another way of declaring a variable based off of certain types of input. And this is saying x is equal to the calling of the variable x plus 1. So the $, and the double parentheses makes it so that you don't have to call on the $, before you say x for it to recognize it as a variable. And this is kind of specific, and this is what kind of makes it funky. There's also a separate logical understanding of if it was only a single parentheses. Each have their own sort of context and function, but you just need to do a good bit of tinkering to understand why you would use it. Otherwise, you'll run into errors when you're trying to define the value of certain variables. But it's saying x is itself plus 1 each time it loops through. That's what's happening. And then you tell it to echo or print to terminal the value of x. And all right, so, and what do you think will be the output of this third example? Anyone? And done is also the completion term for while. So that's that's the while completed by done. But anyway, anybody got an answer for this one? What's logically happening here, and what will you see in the terminal once you run this script for this third example?
You'll probably see. I guess so. That's 1, 2, 3, right? Or yeah,
Yes.
yeah, 1, 2, 3.
Exactly. Well, yeah, and there is one particular distinction I want to make with what the output is, and let's just run the script now. So, running the script, you either state the full cd back out to demo. So I have everything in a Kali home directory and in a demo directory. So you would typically state the full thing to run it. So /home /Kali /demo /name of the script, and this one is called basics.sh. And we're going to get... So the answers were, for the first one, no, do that. You were correct there. And then the next one, you got it correct as well. It's true. And the third one, correct. 1, 2, 3. So some small distinctions in regards to the logic of how if and loops work. Even if a condition is true in the elif, if it was already a success in one of the prior, you can have unlimited elif statements. So this is just everything. Whoops. Even if everything done in an elif is true, if there was a prior statement that was true before and it acted on it, no other elifs will actually execute. An if statement will go until it hits a true clause. So if you want multiple things to happen, you have to create the proper conditions in which both actions will ultimately trigger. So in this case, only this scenario will happen, even if you happen to create the conditions for two scenarios to be ultimately true. And then, with while statements, a while loop won't break the second it meets its condition. So it meets its condition the moment the variable equals 3. But it still prints 3 because it still goes through the process of the full sequence, and then it only decides to stop once it goes back to the top of the while loop. All right? So does that make sense? So sometimes there might be situations in which once something happens, you don't want the things after the trigger, and you have to also sort of craft the logic for it to not do specific things. So that's a whole thing as well, but you'll see the scenarios in which all this applies if you decide to do your own projects. So this is the core of if statements and loops. Everyone sort of keeping pace, everyone feeling good. Anybody got questions?
This might be a dumb question.
Yeah.
And kind of on topic, do you know if there are any, languages that sit on top of Bash? Or is Bash like Python where it's simply, like a scripting language?
Well,
it's on its own.
The thing is, it's innate to Linux as a system. So a funny thing, I haven't tried this out, but I'm pretty confident as a Bash script, Bash and Linux systems are built on C. So although you can't call on C in a Bash script, that's what Linux systems are ultimately built on. So that's the only thing it sort of sits on top of, but you can actually, in a Linux system, as long as it's an executable file, you can just directly call on Python scripts if you have Python installed. So in Bash scripts, you could feasibly call on Python scripts inside of them to make use of other languages, if that is something that kind of answers your question. I'm not sure.
Yeah, that answers the question. Thank you so much.
Okay.
No question is a dumb question, I feel. I just wanted to say that.
Okay. All right. Cool. So that's the basic logic of how those sort of structures work. But now we're going to take a look at something a bit cooler. And to do this, we're going to iterate off of stuff Alex W. went over with Nmap. And we're going to demo it by also nmapping other things in Hack the Box. So I've got that open. But again, to get into Hack the Box, I definitely recommend getting into it. And to get an account, you need to hack their account access page to be given the token to request your access to the system, which is kind of a nifty thing. But once you're in, you've got all these various available hackable things that they give you the permission for to use Nmap on. Let's make this explicit. If you do not have the permission, using port scanning can get you in legal jeopardy. Do not scan, it's highly advisable to not scan people or devices of individuals whom you do not have explicit permission from. So,
Can I interrupt?
Yeah.
Generally, you can't hack anything. That's even some things that are yours. Like if you open your iPhone and you fiddle with the electronics inside, you break a seal, and actually, in some cases, you void the warranty. So generally hacking anything is ill-advised, and unless you have complete permission and it's completely legal, you shouldn't attempt it unless you have created the system.
Yes, exactly. And even port scanning your own public IP address, even your home network, is iffy because you might have roommates, families, significant others, what have you, and unless you gather their explicit permission to do port scanning on their devices as well, or let them know that you're doing this for educational purposes, if they know, they might just not know, but if they know something about technology and they discover that you did this, you could be in legal jeopardy in that regard as well. It's not advised, but that's why Hack the Box comes in handy, because it's an environment where they give you express permission and actually intend for you to hack all of these various devices that users create for the purposes of creating scenarios and different types of machines that you can try to hack. So it's a great little tool to tinker with everything you're being shown here. So, and how you do that, after you do the whole initial hacking of their webpage to get your token and everything, you have to run a thing called, what is this? That's a different thing. You get a token to connect to their VPN. So you need to run it with sudo, and that's sort of running a command as administrator, open VPN. Why is it not autocomplete? It should autocomplete. So, and then I have a token in this directory here. And when it does that, oh, it's not running yet. Oh, there you go. Boom. All right, so it's doing all the things, and this terminal is going to be sort of kept busy. So we're going to minimize that, but that just means now it's registering as being part of their network. So if you see all these IP addresses, this is in a local address scheme. So 192.168.1 is a typical local scheme, and 10. Whatever is another. But you typically wouldn't be able to Nmap these particular devices unless you were already within the overall network. Otherwise, you could only scan public IP addresses, which any network will typically only have one, unless it's a business and it's doing other kinds of things. So, next, let's show you this other script I wrote up. Where's the thing? There's the thing. All right, so we're going to leave this script. Say cancel, X, save, yes, escape. No. Okay, so Nano. Nano is a, so many of you already know, but Nano is a text editor. You have many different options, Vi, Vim, Nano, Gedit. That's all sort of at your discretion in terms of which one you use. I personally like Nano, and create a script called scatter.sh. Also, to see permissions and stuff like that of stuff that's in there, ls will show everything that's in there, and then ls space -l will show you all of those, plus permissions and ownership details. So for the scatter one, for the owning user, I have the read, write, and execute permissions, and I have nullified the permissions for all other people. Now. Boom. All right. So in this script, what we're going to be doing is we are going to iterate through a list of IP addresses and systematically scan all of them and pump out reports for each one and create a report for each, a specified report for each one as well. And we're going to have this be an automated thing where we only use a single command to do so. Oh man, we're running low on time. I did not realize that. If you need to leave, I understand. Please, if you'd like to see this, though, stick around. I'll try to speed this up. I can't explain all of the logic, but I'll try to go through it kind of quick. So we are going to loop through by feeding in a file called iplist.txt. So, and we're going to have a list of IPs, and we're actually going to get rid of all these because I had already scanned these. We're going to save that, and we're going to add in a new list. And as it loops through, it's going to pump, or read is a command where it asks for input from the user. But in this case, since it's feeding from a file, it's going to take each line of the file, and each time it loops through, each line will be added into the variable address. So as it loops through, it's going to tell you in the terminal, beginning to scan, and then it's going to do the full scan. And this is a kind of intense scan going through all 1 through 65,535 ports at a T4 level with the -A and -V clauses. And then we're going to pump in the variable as the target. And then with each scan, we're going to pump the full output to a temporary file called output.txt. And that's going to happen with each loop. So these are all just comments to explain what's going on. And then we're going to pump the value of what's in the text file using a variable cat, and that's saying pump all the text value of what's in a file to the screen. But when you add it to, say, a variable name equals $ in parentheses a function, that then stores all of that content within the variable, in this case, the variable full. We then are going to define a variable name called file, and that's going to be the location of a new text file, which will be the report. And that's going to be in a directory tilde, meaning the current user's home directory. Then you have the demo folder, which we're currently in, and then another folder, reports, which will have stuff. And these are prior reports I had done. And then it's going to dynamically create the name of the report based off of the name of the address. Take note of little sort of squiggly lines, the squiggly brackets here. That's another sort of syntax thing for when you're making dynamic use of variables within strings. Stuff I don't have time to explain, but it's worth looking into. Then we're just echoing a bunch of details into the file. So the first one is overwrite, meaning if any content was in that file prior, we're going to overlap it, and we're going to create a new file, and we're going to just create a new one altogether. And that's going to be, we're going to say the line target is the variable address, and then we're just going to punch in a bunch of labels and stuff. So, and then echoing either quotes or nothing automatically creates a new line. So that's just a default functionality of echo, which makes it handy. So we're just saying target, the name of whatever IP, critical report, and a space for a new block of text. Then we're going to echo, let's see. Now we're going to get into sifting through the output. So with the most recent one I did, I have up in the top left corner the full output of a report. Maybe expand this a little bit. And this is everything a scan might have found. And now to have things react in a particular manner based off of output, you have to know how to know what the output's going to be like, and then how to sift through it to find that which you are looking for. And in this case, we're going to use a function called grep here. And grep functions by you have a value that you are searching by. In this case, the first one we're doing is the word starting. But it has to be taking the information from a batch of information, which typically you'd list a directory or file. But in this case, we're echoing the value of what we put in the full variable, which is all of the output of the output.txt. And so you're going to pump the value of the full variable in quotes. That's important in this case because otherwise, without the quotes, it sends it as a singular string as opposed to including the new lines. And grep gives you each of the lines that have the value you're looking for. And we want the full line. Otherwise, it has a problem searching. This is also the pipe symbol is telling you, take the output of something and throw it into this next function. So we're echoing the full variable and piping it into the search variable grep, looking for our first starting, and then the double sort of greater than symbols, which mean append. Append adds that content to the file without overwriting what it is in that file previously. So that's an important distinction between overwrite and append. And all right, so we're going to find the line which is starting, which if you look in the output file, it's about looking at what is sort of unique output. And the line that says starting is a unique identifier that gives you the exact starting time you started a scan. Then we're going to find port, and that's going to give you the header for this table. And this table is the bread and butter of Nmap. This is the juicy bit you want. It's going to grep for port because that's going to be that line. It's going to pump it into there. And then this is probably the most important line. You're going to grep for a bit of logic. You're going to say a set of logic. The first character is either going to be a number or the pipe symbol, because in this table, it uniquely either starts with a number being the port or a pipe symbol being the content associated with that port. And so this isn't a universal type of logic you can apply to everything, but you have to understand the psychological process of narrowing down what you're looking for in a logical pattern to get the exact output you're looking for, to either throw it into whatever it is you're trying to throw into, or you can throw it into an if statement to then make accurate decision making. So in this, actually, yeah, it's getting late. People are having to leave. Let me just show what I can't, I'll demo a few. Let's go into nano IP lists. So cd out. Well, let's add a few IPs from the list here. That's one I already did. 204. Copy. Paste. New line. Let's add 3. 197. Copy. Paste. And we're going to go tabby 194. Copy. Paste. We're going to save this. We're going to exit. And then we are going to run the script. So .current directory / scouter.sh. Boom, that bad boy is going to run. It's going to iterate through each one. Each Nmap scan might take a good bit of time, but it's ultimately going to pump out some reports. So let's leave here. Let's show the example of a report since we already did this a little bit. These are some that have already been created. And let's say, 10.201 was a decent one. And this is what it resulted in. It gives you the critical report, which I labeled as something showing just the juicy information, so you don't have to go sifting through the full thing. That shows you that 22 SSH is open, 9000 is open, and 9001 is open. And so this gives you that information as well as how many hosts are up and the amount of time it took. You also got some OSs here, so you know what OS and what version they're running. And so that's kind of some of the juicy bits that you can get through using Nmap, but it will give you, and it just completed 2 of them, and it's able to do a whole series of them systematically and pump out unique reports for every single one. And this is a way you can automate a whole bunch of nifty processes. You can even add in the logic to decide to do other types of scans based off of output, and sort of it's your entire playground. You can do whatever you want. Boom, it's done. And you can look into these. So this is 10.10.10.94. And it just gave us all of this. It also gave us some information with an MD5 hash. What do you know? What can you do with this? That's pretty nifty, I think. Now, I don't know. I just threw a bunch of stuff at you all. But anybody have any questions or anything?
And all of this, once we polish it up and package it for you guys, will be available online, either on the GitHub or on the SharePoint once everybody have access to that. Right now, we're trying to build an access point where all the PowerPoints and also videos will be up, and we'll let you know when that is up.
Yeah. But the PowerPoint for the time being is available right in the announcements bit, so you can go there just to download PowerPoint if you want to try out anything yourself. So, all right.
Hey guys, initially before you started, there was a link or a bunch of YouTube video links you had posted. Somebody had posted.
Okay.
Do you know what I'm talking about?
Wait, do you mean the ones in general that I posted?
I don't know. I did not check them.
Okay, but
Before you guys started, I saw there was a bunch of
okay,
links.
yeah, that's a bunch of
Somebody
stuff.
had
Elon,
posted.
yeah, Elon posted a bunch, but those are unrelated. Like that's interesting stuff to watch, but just unrelated to
Yeah,
this.
totally
That's not
unrelated.
related to what
Yeah.
you have gone through now. is it?
No, it's not at all related.
Uh,
It's just some cool stuff.
Yeah.
That's how I
What
just
are they
really
called?
fun.
The things that we were teaching, I don't think we'll ever like tell you like, oh, watch this
Alex,
video
I
on
had a
something.
quick question, if
Yeah,
you can
what's
hear
up?
me.
Yeah, I gotcha.
Oh, okay. By the way, thanks for this amazing presentation.
No
and
problem.
the other Alex too. You
Which
both did
Alex?
amazing
Oh.
things. I was like so
both
overwhelmed.
Alex did a good job.
Yeah,
man. Zimmer and Alex,
But
good job.
my question was sort of like, did you actually finish solving the hack the box? Did this report give you what you needed, or was that like
I got into Hack the Box precisely to do this demo because I didn't know where to give you a legitimate Nmap target without doing anything illegal myself. So I haven't yet gotten a chance to, but some of the information, like, it looks kind of nifty. So I mean, I imagine that MD5 hash could be used for something. Maybe it's the password stored hash for one of their accounts. So I don't know for sure. But I my guess is that it might be kind of useful. So I'm not entirely sure myself.
How are you going to decrypt the MD5?
Well, you don't need to decrypt. Well, that's a whole other thing. You can do hashcat and stuff and run rainbow tables, and that's all tools that are in Kali as well. Alex, yo,
what box is this?
This one is 1010-194, which is 194 is Tabby.
Oh, I have that one. Yeah, I have to solve for it.
Cool.
Me too.
So if yeah,
so like the scans tells you what kind of service it is. Usually that's where you start thinking about like what kind of exploitation you want to run. So for the one I did it's called Blunder, and Blunder is a web server. So one of the port that was open was 80 for HTTP running Apache before, and that's where you start like looking. You go into your browser and actually typing the IP address to see what kind of like HTML thing is up, if there is. So this is where you start, and then where you could like try to get a grasp of everything, and where you pivot kind of. Okay, she left. She kind of asked and left. Okay.
Yeah, well, she's probably tight on time. No worries there.
Yeah, I also think that she's been having trouble with connection this whole time.
We are like 10 minutes over time, so everything's totally understandable at this point. Yeah. So no worries there. But I hope you guys might have found that somewhat useful. I don't know, but
yes, I loved it. Thank you so much, both of you guys.
Yeah,
Alex, I've never actually seen.
No, it was a good presentation, man. You guys did a good job.
Zimmer, I've never actually written anything in Bash, and now that you've cleared up some misconceptions in my brain and why it looks so crazy, I'm gonna start writing a bunch of scripts. So thank you so much.
Excellent, awesome, sweet. So use the presentation, like the PowerPoint I did, in terms of like syntax reference. But if you've got some more advanced things that it doesn't cover, do ask me. I like digging into projects and figuring out new ways to use Bash scripting to do stuff, because I just like there's anything you install in Linux can be scripted. So you can create wacky systems by building off, like wacky systems that do unexpected things by building off of other systems that people have already made to implement in Linux. So I just really dig that bit.